Here's an example of where you are to simplify um, a rational expression, and you have a lot of things going on here. There's a single fraction, but in that fraction are negative exponents, and you're going to be expected to rewrite those with positive exponents in single fractions, reduced form, and everything. So the first thing we need to take care of are these two terms up top that have negative exponents. So I'm going to rewrite those with positive exponents. And if you remember, any base value to a negative exponent can be rewritten as 1 over that same base value to a positive exponent. So a to the negative 2 is going to get rewritten as 1 over a squared, and b to the negative 2 is 1 over b to a positive 2. And that's all over a squared plus b squared. And no, you may not go through and cancel the a squareds and the b squareds because there's a whole lot more going on besides multiplication and division. The next thing we need to do is get this top quantity as a single fraction so that we can invert and multiply the bottom, the a squared plus b squared. So I have two separate denominators, and what I need to do is make them be common. So I'm going to multiply the b squared to the 1 over a squared, and then I'll multiply the a squared to the 1 over b squared. So what we have now is b squared over a squared b squared plus a squared over, I guess I could write a squared b squared, it doesn't matter because it's multiplication, but our denominators are the same. And now I can take and add across the top, so that will give me a squared plus b squared over a squared times b squared. Again, you cannot simplify any of that, and that's all divided by a squared plus b squared. So now I'm going to take this big division bar that I made excessively thick because I want to take the a squared plus b squared over a squared b squared and think of it with a division of the a squared plus b squared, so that in turn I can take my first fraction and make the division multiplication, and then take this a squared plus b squared and flip it or invert it, do the reciprocal, whatever your favorite word is, and it would be 1 over a squared plus b squared. And now, since I have a quantity of a squared plus b squared, I can cancel that. It's not term for term, it's canceling the entire quantity of a squared plus b squared at the same time. So now on the numerator all I have is 1, and on the denominator all I have is a squared times b squared. And that's your final answer.